This is a video demonstrating our project for EC311 course at Boston University. This project is about Morse code trainer.
Our Morse code trainer aims to continue the legacy of Morse code and bring its features to a broader audience. The letter-by-letter translation allows users to develop a clear understanding of Morse code translation and timing, while the adaptable speed settings allow the device to be configured in 4 separate learning speeds to suit the user's practice level. Our on-device display is also conducive to learning, as there is no need to switch your line of sight while practicing letters. The specifications our team had going into the project consisted of recognizing the difference between dots and dashes based on user input and compiling them into Morse letters, translating those Morse letters into English, displaying the English live as the user is typing, and including both a single character delete button and a screen clearing reset button. Unfortunately, we were unable to accomplish the addition of a delete button or a functional space being printed properly. Additionally, the project initially specified that the display be on a monitor rather than a 7-segment display. We were also unable to meet this requirement due to time constraints. However, our team feels that the on-device display better suits the training motivations of our device. Despite having multiple failures in our design, we also have a variety of successes. Our device has adaptable Morse input speeds and 2 LED lights that alternate each time unit to display the input speed setting. Moreover, we accomplished having both dots and dashes linked to the same button rather than the easier 2-button design. Some features we would add if we were to continue this project outside of the scope of this class would be implementing an on-device LCD display, adding text-to-speech that reads aloud each letter as it is typed, and implementing the planned delete button.
The clock divider module is standard. To implement the manual unit time changes, the module requires 3 inputs: 1-second unit, half-second unit, quarter-second unit. These are connected to our 3 switches. If the first switch is on, the 100 MHz clock from the FPGA slows down to about 2 Hz. If the second switch is on, it slows to about 4 Hz. The third switch is on, it slows to around 8 Hz. If a combination of these switches or none of these switches are on, then the default is 1 Hz. This allows the user to effectively change the unit time to their desired length.
The button to Morse module handles the translation from button presses to Morse code. It requires 3 inputs: a slow clock, a reset signal, and a button input signal. We represented the dots and dashes with 2-bit registers, a dot being 01 and a dash being 10. The module outputs the Morse code, letter done, and 3-bit Morse index, which tracks the current symbol index. The 2 parameters, 1-time unit and 3-time units, are used in the code to detect a dot, dash, and when a character is completed. The latched Morse register is an array with 5 elements, each element being 2-bit. It stores the bit for the Morse code before a letter is detected as complete, then moves them to the Morse output once detected. When the reset button is pressed, all the variables are reset to 0, effectively restarting the character detection process. Otherwise, if the button is pressed, the 32-bit count register begins incrementing on every clock cycle. When the button is released, the counter stops and the 32-bit inactivity counter begins incrementing. The code then sees if the count is greater than or less than 3 time units. If greater, a dash is detected and the bits are stored in the first latched Morse element. If less, the dot is detected and those bits are stored. When the bits are stored successfully, the Morse index increments so that the next symbol can be inputted. When a character is complete, the button has to be inactive for at least 3 time units. So when the code detects that the inactivity counter is greater than 3 time units, meaning the button is not pressed within that time, the Morse code bit representations are outputted. The letter done output is flagged when this occurs. Depending on the current Morse index, the code will also make sure that the remaining unused Morse outputs are set to 00, noting an invalid symbol. The Morse index then restarts.
The Morse code decoder module is used to change the Morse code sequence to ASCII equivalent. Any letter or number can be represented with a sequence of 5 dots and dashes. Therefore, we use 5 variables, each storing either a dot or a dash. Then we traverse the binary tree using those variables until we find the desired letter. Finally, the module outputs the ASCII equivalent of the letter which we found on the binary tree.
Here we have our FPGA board. Our first feature are the 2 LEDs, 817 and K15, that blink alternately to show the timing of the cycles. Each blink represents 1 cycle. The default time for each cycle is currently 2 seconds, but it can be changed using these switches for training purposes. Turning the switch V10 on changes the cycle time to be 0.25 seconds. Turning switch U11 on changes the cycle time to be 0.5 seconds. while turning switch U12 on changes the cycle time to be 1 second. Here we have LEDs starting from T15 going up to U11 that represent the index of the display. Each time an input is recorded, the LED shifts to the right, indicating that the input has been taken incorrectly. Lastly, we have the buttons. Button C here is used to take the input as dots and dashes to be converted into ASCII and displayed on the screen. Button L here is used to reset the entire segment display in case you make any mistakes or want to train again.